So we're going to continue our conversation on how to move a line. We call it transformation. And the new concepts we're looking at today is called reflection and on the x-axis, and then reflection of the y-axis. When we think of a reflection, we often use a mirror. And so reflecting on the x-axis would just reflect it as a mirror into a graph. Actually. And then the y-axis, same thing. That one would be more this way. So we'll look at it right now. So let's read it over. A reflection is a transformation that flips a graph over a line that's called the line of reflection. Reflection in the x-axis. The graph of y equals negative f of x is a reflection in the x-axis of a graph of y equals f of x. So again, this one would reflect more like this way. Show you, kind of show you, a bit challenging. There, that's sort of it. But whatever you have on one side, you would have reflected on the other. And that's if it's negative f of x. So another way to look at that is by multiplying the outputs by -1 and changing their signs. We'll demonstrate that in a little bit. But notice it's the outputs that's being multiplied by -1, the outputs. So when we're talking about a negative f of x, remember f of x is the same thing as y. Let's review. And so a negative f of x is like changing the y. And that would reflect on the x-axis. But reflection in the y-axis is changing the inside of the parentheses. So that's like changing the x to a negative. And that would reflect on the y-axis. So it would reflect up and down like this. It's a little bit easier to show you this one using a mirror. You can see the same thing on both sides if I can get it just right. There we go. Exact reflection. So that's when you're multiplying by a -1, but it's on the inside of the parentheses. That's a reflection of the y-axis. On the outside would be a reflection of the x-axis. So let's go ahead and look at these practically and see how they look. So the question says, let f of x equal half x plus 1. Remember, it's the same thing as y equals mx plus b. And then it wants you to make this transformation. It says, let g of x be a negative f of x. So we'll go ahead and do that. Sorry for the email message popping up. And then then it also wants us to do another change, but this time that it's changing inside the parentheses and making it negative. So basically two changes, two transformations are being made. And we have to describe it. Is it a change of the, on the y-axis as a reflection or the x-axis? So first thing I'll do is graph this real quick. That m is half, or 1 over 2. The b is a 1. So we'll start at 1 and we'll go up 1 over 2, up 1 over 2, up 1 over 2. And I'd like to go reverse 2, down 1 over 2, down 1 over 2, down 1 over 2. It just tells me to do a nice and straight line. So we'll do that real quick. Oh, see, kind of helps. Those guiding points. Okay, so we have the one line. Now we need to reflect it. In order to reflect it, going back to our instructions, let's put it back up real quick. It says with a negative f of x. So we're going to do a negative f of x real quick. And so, oh, more messages. Hello, people. So a negative f of x. So it does help to have some numbers kind of to think of, to choose. So if x, I'm looking for places where it's solid. So a solid place would be right here. -2 is a pretty solid place. What I mean by solid is not a fraction. See, like right here, -3 would not be a good place to choose. -4 would be an okay place to choose. -6 would be okay. 0 is okay because it's not a splintered. It's not like part of a line. It's the whole thing. So I'll choose these to be my numbers. So if I were then to reflect it, I would do the opposite of that, right? And so what is -2 multiplied by a -1? What would that be? well, a negative, let's find out what that would be. Or actually, we should probably start with a negative 4. Let me change that and go in order. Negative 4, negative 2, and 0 is the order it would go in, right, if we were to go from left to right. And so if we were at a negative 4 for the x, what is the y at? Negative 1, negative 2, negative 3, negative 4. Why is that a negative 1? Why is that a negative 1? So if I were to multiply that negative 1 by a negative 1, it would turn into a positive 1. And so if I were to reflect this, it would be at a positive 1, right? And if I look at negative 2 for x, negative 2 is at 0 for y. So if I were to reflect a negative 2, it would be at 0 for y. Well, the opposite of a 0 is still 0. If I were to look at 0, it's at a positive 1. But the opposite of a positive 1 is a negative 1. So we go to negative 1. And what we start to see here is the reflection along the x-axis. If I were to draw a line, it looks something like this, with this being the line of reflection. Okay, so that would be the answer to that question. This is how you would graph it, and this would be the, if I were to kind of sum it up, this would be the x-axis. I mean the x line. This would be the f of x, or the y, and this would be a negative, I don't know if I'm going to be able to fit that here, times the f of x. Cool. All right, let's try it again, but let's reflect it this time instead of off the y-axis, off the x-axis. I've already graphed it. I've already graphed the line here, and we could do the same exact thing we just did, and that's that. But remember, this time instead of the negative hitting the f of x, it's going to hit the x. So that changes where it reflects at. Instead of reflecting on the y, on the x-axis, it's going to reflect on the y-axis. So one way you can do this is just multiply instead of multiplying the y by the negative, remember last time we multiplied the f of x by the negative, we'll multiply the x by the negative and see what we get. So if the x is a negative 2, this upcoming time we multiply the x by a negative, it would become a negative 2 times a negative would become a positive 2. And then if 0 were multiplied by a negative, it would still be 0. Well, that makes sense. Sorry guys, I'm getting a lot of text today, popular day. And then if x were a 2, you multiply that by a negative, it'd be a negative 2. So if x were a 2, you multiply it by a negative, it would be a negative 2. So x would be a negative 2. Sorry, if x were a negative 2, so what we find here is a reflection this way along the y-axis. Whoops, I missed the dot a little bit. Now one way you can fill this in, it's kind of nice, is multiply it by the opposite of each one for the x, and then see what the y would be. So if x were a 2, what would the y be in that case? Well, if x is a 2, the y would be a 2. If x were a 0, y would be a 1. If x were a negative 2, looks like it would be a 0 here. I just missed it. So you can do this just by using the chart as well.